Welcome. In this video, we are going to model trend and seasonal component of time series data. Quarterly car sales data in thousands, trend and season, cycle, irregular are the four components. Here we are modeling trend and season. So I'll provide the whole Excel spreadsheet in this link. You can click on this link in the video and you will get it. So you'll just click on this and you will get all this Excel spreadsheet. So we have this data. Now if I plot this data, you'll see there is this is quarterly data, 4 years data. This is my 4 years data and we are going to forecast data for the 5th year. So if I plot this data, you'll see that there will be clear pattern of seasonality, and you can just have horizontal axis as well. So if we fit a trend on this data, if we fit a trend line, you will see that this trend line basically overestimates for quarter 1 and 2 and underestimates for quarter 3 and 4. If I project this line and we want to forecast for year 5, then it means when in quarter 1 and 2 we have low sale, it will give a high forecast, and in quarter 3 and 4 when we'll have high sale, it will give a low forecast. So that's why in this case, beside this trend component, we need to have seasonal component. We must have seasonal adjustment as well. So how do we do that? First of all, we need to find out what is the seasonal component magnitude, what is the trend. So to overcome seasonality, what do? We take the average of these 4 quarters and then the average of these 4 quarters, and in this way we have moving average here. Moving average basically aggregates data and eliminates seasonality. So you have all this one, and then you can center moving average, that is moving average of this one in cell E and E6, place it in front of quarter 3, and similarly place it in front of quarter 2. So 2 quarters in the beginning, 2 quarters in the end will be missed out from your data. That's one of the drawback. Now you have this trend line, you have this one aggregated data, and you see here you don't have any seasonality when we plot this center moving average. Now we have D6 is your actual value, D5 is actual value divided by center moving average. That will give you seasonal component, that will give you seasonal irregular component, and in this way you can keep on dragging it and you will have all this seasonal component. Now you see you have quarter 3 here, quarter 3 here, quarter 3. You need to average. Basically this may not be exactly 1.11. so if I take slightly more decimal places, you will see it's not exactly. So quarter 1, this is 1.10, this is 1.08, this is 1.11, and you need to take their average. We are going to use average if command here. So average if command, we have used average if. You see, we have used conditional if quarter 1 average, if quarter 3 average, if quarter 4 average. So you can also learn Excel during this one. Another one is VLOOKUP. Instead of copy and paste, I am using VLOOKUP function. So please, you can use this VLOOKUP function. Learn this VLOOKUP function, very useful. Here when you have quarter 1, match it the value here. When quarter 2, match it from here. Because if you have 50 years data or very long data, or you have 2 separate sheets, then this VLOOKUP is a very useful function. At the moment I am not going to discuss it anymore. So you have this seasonal component, again the same seasonal quarter 1, quarter 2, quarter 3, quarter 1, quarter 2, quarter 3. Then you have deseasonalize this, that is you divide actual data by the seasonal one, that will be your deseasonalized data. Another one is to fit a trend. If I fit simple trend by simple linear regression, you can go to data analysis and you can fit OLS. I have used linest function, that is, I have regressed car sales data on time trend 1, 2, 3 up to 16. This is our intercept, this is our slope, and this is our fitted line here. You see, I have fitted line here. That is this intercept N13 plus slope coefficient M13 times time trend. But when we use this fitted line, you have this trend component and you have actual value. So this is exactly what we have seen earlier. Alt N1. So this is exactly the same thing as we done earlier. Now when we project this for next year, so here we are going to, I'm going to basically copy paste, Control V, here year 5. This is my year 5 for which we are going to forecast. And here you will have trend values up to 20. And when I will, this one is my, basically, if you go, so you have trend here, this trend column, and now if I drag it down, so you have this intercept and trend same way. And if I fit it, and this one, final one, basically this final one is, that is what we have achieved, that once you have this trend, once you have season, you will multiply with each other if they are multiplicative components, and forecast it for next for 5th year as well. So okay, some error here. Okay, yeah, because we have not mod the seasonal component here as well. So no, it's okay. We have this one original series. Let's final 1 minute. Alt N1. Quarterly data. Select this data. Okay, and one way is just fit this trend as well, copy paste, Control V. No, if you just, this orange line is your, basically if just you fit a trend, that's wrong, because you have ignored seasonality. So I am going to rub it. I'm going to rub this orange line. This gray line is your forecast. Blue line is actual data. This gray line is your forecast. So you see this 5th year. So that's why we need to model trend and seasonal, all stationarity, non-stationarity, unit root, and all those things are linked with modeling this trend and seasonality. That we'll see at some other stage how R can do it with a single click. All 4 components are displayed separately. We'll learn those things, but in Excel for simple business forecasting, if you need to model these components, how you can model these components, this is the way. Thank you for watching. Take care.